Function Standard 1. We're going to look at representing functions. We're going to start with our first learning target. I can explain if a graph, a table, an equation, or context is a function or not a function. So in other words, we're just going to be looking at different representations in math and determining if that representation is a function or is not a function. So the first question you should have is, what is this function? So functions relate or connect a set of numbers to another set of numbers in a particular way. So in a table setting, if you look at the x or the input values and you look at the output values, is there some type of connection or relationship between those? Or we could look at a graph. Is the x coordinate somehow related to the y coordinate? So the first thing we're going to look at is what makes a table a function. So when you look at a set of ordered pairs, you're going to see if the input has only one output. In other words, there should be no repeating x values. So this is the equation I used, y equals 2x plus 3, and I just inputted -2, and then my output was -1. Same equation, I made an input or an x value of -1, I got the output of 1. 0 was my input. My output into that equation was 3. 1 was my input. My output was 5. And the last one, 2, was my input. My output was 7. So if you go back to the definition here, you're going to say if each input has exactly one output or y value. So the input of 2 had -1. Input of -1 had 1. 0, 3, 1, 5, and 2, 7. So that is an example of a function. So let's look at what's not a function. So if we look at this input of -5, it got an output of 4. Well, when I quickly look at my x's, I also notice I also have another -5. So I have an input of -5, and I have an output of 4, but I also have an output of 7. So if I visualize that, so if I had a table, my input here is -5, my output is 4, and my output is 7. That is not an example because this one input of -5, so this is my input of -5, had 2 outputs. If you go back to the directions or the definition, each input or x value has exactly one output or y value. Again, we can look at that same idea with zeros. The input was 0, my output was 3. You input again 0, and now you have an output of -1. So looking at that other part of that definition, in other words, there should be no repeating x values. So notice that the x values are repeating. That means there's 2 outputs. So that is an example of not a function. Let's look at what makes an equation a function. So an equation represents a function if every input will only result in one output. So this time we're actually going to make a table, but this time we're looking at an equation. So my equation is y equals x squared plus 6. So my input is -2. So if I take -2 squared plus 6, well, -2 squared is 4, plus 6 is 10. Next one, if I take -1, I square it, and I add 6. So this is 1 plus 6 is 7. If I square 0 and add 6, 0 squared is 0, plus 6 is 6. If I square 1 and add 6, 1 squared is 1, plus 6 is 7. And the 2, if I square that, would be 4, plus the 6 would be 10. So if I look at this input-output, I notice that every time I inputted a value in for x, I got a different y value, or just one y value, or one output. So be careful. This one, people want to tell you this is non-functional because you see 2 outputs that are the same. That doesn't mean it's not a function. It can't have repeating x values. It can have repeating y values, but not x, because every input has one output. Okay, if you go back to the table back here, the input of 5 had 2 outputs, 4 and 7. The input of 0 had 2 outputs of 3 and -1. So going back to this table or this equation, this is an example of a function because every time I put an input in, I got one and only one output. So we're going to look at a non-function when it comes to a table. So we have the equation up here, y squared equals x. It might be easier to understand if we flip that around since we're inputting the x. Let's go x equals y squared. So I just flip those around because they're equivalent, so that means they're balanced. So I can just flip one to the other. So on this, we're going to input 1, and we're going to get what could be our output. So if I input 1, so 1 equals y squared. So I'm looking for the output of y. So this is our x, and this is our y. So what can I square to get 1, in other words? So 1 squared definitely equals 1. And then if I want to get another 1, so go back to this equation again. So 1 equals what squared? Well, y could be negative 1 squared also equals 1 because negative 1 times negative 1 is 1. If I have the input of 4, so x is 4, and I'm looking at what squared equals 4. Well, the easiest one is 2 squared equals 4. So my x would be 2. I'm sorry, my y would be 2 because this is that value right there. And then 4 equals y squared. So in other words, 4 equals what squared? So negative 2, if you square it, equals 4. So negative 2 is my y. Oops, I forgot to put negative there. Okay, if we plug in 9, so 9 equals y squared. So what do we square? In other words, that gives us 9. So 9 is the same thing as 3 squared. So my output would be 3, because this is my y values. Or 9 equals y squared. So what could y be? Well, y could be a negative 3, and we square it equals 9. So why this isn't a function? Well, you notice if you plug in an input, you get 2 outputs. So when I plugged in 1 as my x, my output of 1 and negative 1 happened. When I inputted 4, I got 2 and negative 2. So not every input has one exact output. The inputs have 2 outputs. Or you can look at it as repeating x values. So notice that this equation is not a function. So what makes a graph a function? Well, the graph should pass what we know as a vertical line test, which means that any vertical line drawn on the graph should intersect the graph at just and exactly one point. So draw my vertical line. Notice the graph only intersects at that point of negative 2 and 4. Draw a vertical line here, it only intersects once. Draw a vertical line here, it only intersects once. Draw a vertical line, intersects once. Draw a vertical line, intersects once. So this first one is an example of a function because every time I drew a vertical line, the graph only crossed once. Again, that's known as the vertical line test. And that makes total sense because x would be your vertical idea. So when I input 2, I only got the one input output of 4. When I input 1, I only got one output of 1. When I input 0, I got an output of 0. When I input negative 1, I got an output of 1. And when I input negative 2, I got an output of 4. And again, we can do it without lines drawn. So there's a vertical line. So we input 1, we only got one output of 3. Vertical line only hits once. When I input 2, I get an output of 1. Here, once. When I input 3, I get an output of negative 1. 4 only hits here at 2. It only hits the line once here at 5. It only hits a line here once at 6, an output of 6. So those two are examples of how you can see they are functions. These are examples of not functions. So again, that vertical line. So that vertical line still proves a function because when I input, it looks like 1, I get an output of 2. But this one right here is the issue. When you input 2, it looks like you get an output of 1, you get an output of 3, and you get an output of 5. So that means that this one input has multiple outputs. So remember, to be a function, an input has only one output. So that is not a function. Vertical line test here. Just draw a vertical line. Let's do it right here. So when I draw a vertical line, the graph hits the line there and the graph hits the line there. So that means that input of x, because remember this is your x value, when I input x, 6, I get an output of looks like 6, or I get an output which looks like -2. Again, you only have to test it once if it fails the first time, because if it fails the first time, that means it's not a function. What makes a context a function? Well, same thing I keep saying over and over. If the input has one output. So here's an example of a context of a function. A basketball team has 15 players, and each player has their own assigned number. So you can think of it kind of like a table. Here's a player. I won't draw 15 of them. I'll give you an example here. So there are 5 of my players. Well, player 1 gets the number 1, player 2 gets the number 5, this player gets the number 7, this player gets 12, and this player gets 16. So each player only has one output. Okay, so we think of this as our input, and we think of this as our output. So each player has one output. If we look at this context, this one's not a function. So it says a football game is being broadcast. So we'll say this is my beautiful little TV with the antenna. So we'll say this is my TV here. I got a football game going on. Beautiful football. Beautiful. He's getting past this guy over here. Okay, so there's my football game that's being broadcast, and then it appears, the output, it appears on a million televisions. So here's the game that's being broadcast, and it's going to appear on many other people's, a million in this case, TVs. So one broadcast has a million outputs, so that definitely cannot be a function. So hopefully this video explained to you how you know it's a function or not a function.